Welcome to SysEng Quick. My name is John, and today we'll use Ansible to configure our Fedora VM to run containers with Podman. Podman is a Docker alternative developed by Red Hat, which focuses on security. Podman containers typically run without root privileges, and there is no Dockerd service equivalent. Services running in Podman containers are managed by systemd, and the Podman CLI is built to function as a drop-in Docker replacement. This makes it easy to use for anyone with prior Docker experience. Let's get started. In VS Code, I've got the setup router playbook we made last time. I'm going to make a copy of that, rename the copy to setupvault.yaml. This will be our playbook for configuring our VM to run HashiCorp Vault. Okay, so we are still targeting the proxy host. We are now going to install Podman, so let's do that. And we'll change our role to Podman. And that should be a good start for our playbook. Let's go ahead and start working on the role. So down in our roles, we'll make a new role called Podman. We're going to have some tasks, and the main task will install Podman. So let's start by doing that. We will install Podman. We're going to use the package module to do that. The name is Podman. I do want to update the cache, and don't forget to become root or we won't be able to install things. Okay, that looks good for our role. Let's go ahead and try to run the playbook. On the command line, we'll do Ansible playbook, syseng quick tutorial setup_vault. Okay, it looks like everything was installed successfully. Let's test that out. We will SSH as the Ansible user into the ATH-proxy host. And let's try doing podman run, and we'll remove this after we're done. And we're going to run the container hello-world. So let's see if that works. It's pulling the image, and yes, hello podman world. So Podman is able to be run on our system now. Now that Podman has been installed, let's work on installing HashiCorp Vault. So I don't want to use the main role here because we may do other things with Podman in the future. So let's go ahead and add a task from section, and we use the task from the Vault. So let's go ahead and scroll down to our Podman task. We'll make a new file, vault.yaml. And the first thing I want to do in here is simply install Podman. So we could include the role twice in our playbook, but I don't like that because it makes it more confusing. I want to do Vault. Vault depends on this. I'd like all the dependencies to be right here in this task file. So we can do that by simply importing the task file right here. There we go. Now we will run the Vault task, but it will also import our main task to make sure Podman actually gets installed. Next, we need to make a non-root user. Podman is going to run our container rootless, and I don't want to use the Ansible user because it has too many privileges. It's not purpose-built for this, and I want a purpose-built user. So let's go ahead and create non-root user for Vault. To do that, we'll use this task file over here, the main task, from the user role we created many episodes ago. So we're going to import this role, and the name of the role is syseng quick tutorial.user. We need to supply the vars, which has the username. I'm going to call it the Vault user. Okay, that looks pretty good to get our non-root user, but in order for Ansible to be able to switch to that non-root user, I need to install the ACL package on Fedora. So let's go back to our other task file in Podman, and because we'll have other non-root users, we'll go ahead and do that right in here. So we can install more packages, or we could supply an array to this instead. So we have a couple of options. Doesn't really matter, but let's go ahead and install ACL here as well. Okay, so now we'll have Podman and the ACL package installed, which we need to do our task. Let's go ahead and make sure that our playbook is still working. We'll go to the command line, and we'll do Ansible playbook sysenj quick tutorial setup vault. And let's see if this works. Okay, we've got that. We create our user. Yeah, everything looks good. We should have our new non-root user. There is a collection we can use for working with Podman containers. Let's go ahead and install that. We'll go to the terminal and we'll do Ansible Galaxy collection install containers.podman. It's going to install version 1.13.0. Let's go ahead and make sure that is in our Galaxy dependencies. So we'll go back to our files and go to open galaxy.yaml. Let's go ahead and paste that in there. And we will make a version range of greater than or equal to the version we have, and then less than or equal to one version higher. Okay, that should be good for getting our dependencies sorted and having our container installed. We'll go ahead and close that. And let's go ahead and try to fetch the container. So let's pull HashiCorp Vault container image. To do that, we can use the containers.podman.podman image module. Okay, we need to give it the name of the image, which is going to be docker.io/HashiCorp/vault. Latest is the default, and we need to tell it docker.io because for some reason HashiCorp Vault has things in many registries, and Podman is not quite sure which one to pull from by default. Yeah. That's a Podman quirk, but it's fine. Let's go ahead and see if this works. And we'll need to go ahead and make sure we become the different user. And then I will become that user, which is the Vault user. And let's go ahead and see if this is able to be pulled down. So we'll run our playbook one more time. And there we go. Everything looks good. We should have the container image ready to go now. Let's configure some directories for our HashiCorp Vault files. I want to place them in the user's home directory, so we'll need to get that path. We can use the user info module we created a few episodes back. We'll say username is Vault and register that in the result variable. Next, I want to register a fact to hold our data directory. So we'll say register data directory. We use the setFact module, and we're going to set the fact vault_data_dir. And we're going to save the user info's home directory, and then I'm going to place everything inside there in a folder called data. Now we can start creating this path and a few others under it. So let's say create config directories, and we're going to use the file module to do that. So we have the state, which is going to be a directory. And then our mode property is going to be 0700. But what is our path property? Well, we have this directory, but we also have 3 directories I need to create under this. So rather than run this module 4 times by copying it, I want to run it as a loop with all 4 directories. To do that, we'll use a loop construct. And we're going to set the path is whatever is in this item variable. So how do we get this item variable? Well, we supply it with the loop property. In a loop, we supply an array. And every time it runs the file module, every element of the loop, one at a time, gets placed into this item variable. So if I say the first value of loop is Vault data directory, then if I run this playbook, we'll see file being run with the path of Vault data dir. And now I can go ahead and add my subpaths for config, file, and logs. And now we'll run this one task 4 times, once for each of our items. But we also need to become the Vault user here. Let's go ahead and do that as well. So let's say become is true, and our become user is going to be the Vault user. So that will create all of the directories inside our Vault user's home directory. But that won't actually work for our container. Podman is going to run this rootless, which means the actual user that Podman is using will not have the user ID, and won't be able to write things to our file directory or our logs directory. We need to make sure that it can do that. To fix that, what we'll do is use Podman unshare to change these permissions to the correct user ID. And so we'll do that by using a handler. So we're going to say notify update vault config perms. And then we can go make a handler that registers this change with Podman unshare. Let's go ahead and copy this over, go back to our helper, and let's go ahead in our handlers file and add main.yaml. So our first handler is going to be named update vault config perms. Remember, handlers must match whatever you call them in notify. And then what we're going to do is run the file module again. So inside file, our state is directory, and our mode is still 0700. And our path is going to be, once again, item. So we're going to loop over the two directories we need to change. We'll set the owner to be 100. This is the user ID that Vault uses inside the container. And the group is going to be 1000, which probably doesn't match our new users group. So we'll set that as well. We set loop one more time, and this time we're going to have vault data dir /file and vault data dir /logs. I don't believe the config directory needs to be set, but if this doesn't work, we'll go ahead and fix that a little bit later. The last thing to do is make sure that we become the right user. We can't do Podman unshare from the Ansible user, or we'll have the wrong user ID. So let's start by saying become is going to be true, and our become user is going to be the Vault user. We need one more property here, the become method. Become method has always been sudo for us, but here it's going to be the Podman unshare from the containers Podman collection. This is going to be containers.podman.podman unshare. So this is how we'll change the ownership and group of the file and logs directory to match the correct user ID and group ID inside the Podman container. Let's go ahead and save that, and let's see if it looks correct. Let's go ahead and run our playbook one more time, set up Vault, and you can see it create our directories, one for each entry in the loop, home vault data config, file, and logs, and then it ran our handlers at the end where it changed things for home vault data file and logs. It didn't do anything with data or config because we didn't loop over those. Let's see what things look like on our server. If we go into our Vault user, look at the directory, we can see it did create this data directory and it's owned by our Vault user. If we go look in here, we'll see that our file and log directory is owned by, well, I don't know what that is, but it has no meaning outside the container. But inside the container, this will be user ID 100 and group ID 1000. Now that our directories are in place, let's go ahead and make a configuration file. So let's copy the config file, and we're going to use the copy module to do that. The source is going to be vault server.json. Destination is going to be our vault data dir /config/server.json. And our mode for this will be 0644. I don't think there's anything sensitive in here right now, and it will need to be world readable unless we change the permissions of the config file or config directory so that our user inside the container can read it. So this should be fine for now. If we have to change that, we'll go ahead and fix that a bit later. Let's make sure that we become true and become the right user. So we'll go ahead and do that as well. And then let's go ahead and make that file. So in our Podman role, we'll do files/vault server.json. And I'm going to go ahead and copy this over here. So we've got this as our HashiCorp configuration. We're using file storage, and the path is /vault/file. We've got a single listener on TCP port A200. We are disabling TLS for now, but we'll fix that a little bit later. We've got a default lease time and a max lease time. We are disabling mlock. We have to do this with rootless Podman because we can't give mlog capabilities with rootless Podman. And I'd like to keep it rootless, and for what we're doing, it shouldn't matter. But we could run this as root on Podman, and it would be fine to add the capabilities. And we'll go ahead and enable the UI as well. So let's see if this works. We'll go to the command line and rerun our setup vault playbook. Okay, there we go. We copied the configuration file. So let's go see if that worked. If we go into our user, into our data directory, into config, yes, server.json is here, and it looks good. I think we're ready to create our container now. I've restructured this just slightly to add a block so that I don't have to repeat these become user properties for each of our tasks that need them, since there are several of them. So now we create the config directories, copy the file, and pull the container image. So if I were going to run this container from the CLI, I'd probably do something like this. Podman run, remove on quit, name it vault, expose port A200, map the volume data directory with SE Linux context, since we're using Fedora, which has SE Linux enabled by default. This is the image name, and here is our command. So let's translate that into an Ansible task. We can use the Podman container module to do this. So let's say create HashiCorp vault quadlet. A quadlet is a Podman, hook into systemd to make generating systemd files easier. So let's view the Podman container module. We're going to name our container HashiCorp Vault. The image is going to be HashiCorp Vault latest, so we'll go ahead and put that in there. Then we can have the state, which is going to be quadlet, because we're not creating a container, we're creating a quadlet file, which will hook into systemd to start our Podman container. Okay, we can add our command, which is over here at the end. Let's just copy all of this. The ports we want to expose are in the ports command, so let's go ahead and copy those. We also have volumes, so let's do that. It's going to be pretty much this, except we're going to change this relative path because we know the exact path. It's vault data dir. And we need to quote this for YAML, so let's go ahead and do that. And then we need to supply some quadlet options. So I'm going to supply some install options. This is going to add things to our systemd unit file. I'm going to say wanted by equals default target. This will make sure that our service gets started on boot, which is something that I want. So as soon as we've made this quadlet, we need to hook into systemd to reload our service. That way, this service file will get created from the quadlet file. So we're going to do a notify, and I'm going to say reload systemd daemon for vault user. So we'll need to go ahead and make this handler. So let's go ahead and go into our handlers file. So up here over in main, we can go ahead and add to this. So the handler we want to make is our reload systemd. Let's copy this to make sure I don't typo it. And what is it going to do? It's going to run the systemd module that is built into Ansible. And the name is going to be HashiCorp Vault. I do want this to be enabled, and I would like it to reload the daemon. The scope needs to be user scope, and I want the state to be started. Okay, that all sounds pretty good. Once again, I need to become true and become the vault user. However, this actually won't work because sudo does not give us a systemd session, and we need one. So to fix that, we're going to use a new become method. It is community general machine control. This will allow us to use machine control to switch into another user and give us a systemd session for that user, which will enable all of this user scope stuff to work properly. Of course, there are a few more caveats with that. For instance, we don't have machine control installed on our Fedora host. So let's go back to our main task and make sure that it installs that. So up here in our packages, we're going to add systemd container, which is where the machine control binary comes from on Fedora. And let's just change this name. It's no longer Podman packages. So that looks pretty good. We need to actually do one more thing, so let's turn this into a block. We're going to become root, and we'll change this to go up here and put our block in there, and then we'll indent this task. And now, next thing we need to do is add a policy kit rule, because only the root user is allowed to run machine control, and unfortunately, our plugin for our handler, our machine control plugin, will not actually prompt us for a password. I'm not sure why it's that way, but it is that way. So we have to enable our Ansible user to run this without being prompted for a password. So let's say add policy kit rule for machine control. And we're going to use the copy method. And our source is going to be, I'm going to just call it file. Our destination is going to be the exact same thing, but with a slash in front. And then the mode is going to be 0644. And for vars, I'm going to say file is etc polkit1 rules.d 60/machine control/wheels.rules. Okay, so this file goes in the etc polkit1 rules.d directory. I'm calling it 60, which gives it a priority. This name, just whatever you want to call it, just make sure it ends in .rule. That's the important part. So let's go ahead and copy this and make a new file. So up in our files, we're going to make a new one, etc polkit-1 rules.d 60-machine control-wheel.rules. Okay, and policy kit rules are added with JavaScript. So actually not too difficult to do. I'm just going to copy paste this over here. So what this does is that we're going to add a rule to policy kit, and we give it a callback function. And so if the action says, I want to open a new host shell, and whoever's asking is in the wheel group, just let them do it. Don't prompt for a password. Our Ansible user is effectively the root user on this VM host. So we'll just let it go ahead and do that without a password. So we'll go ahead and save that. I think that's it for policy kit and machine control. So the last thing I think we need to do over here before we can try this out, I want to add another handler. So one thing we haven't done yet is I would like it to restart our service if this file changes. So let's add another notify handler over here. So let's call that restart HashiCorp Vault service. Okay, that looks good. Let's copy that. We'll go back to our handlers and let's copy that. And now once again, it's going to be systemd, and we're going to do all of these same things with the become property. Let's dedent that. The name is HashiCorp Vault, and the state is going to be restarted. Okay, I believe that is everything. Oh, forgot the scope. Scope needs to be user. Yeah, that looks good. Okay, so yeah, now we will restart our service anytime we change that file. I think I will leave out the state over here on this first one. It's going to be started automatically by this the first time it gets loaded anyway. So that should be fine. Okay, if I haven't made any typos or forgot anything, this should be good to go. So let's go ahead and test that out. We'll run the playbook, sysng quick tutorial setup vault. So it's installing our Podman packages. It should get us our machine control binary. We've added the policy kit rule. Looks like I already have some files, so that means some things didn't quite work. So we got the reload systemd daemon, but we didn't trigger anything to actually start because we didn't change that file. So let's go ahead and fix that real quick. Let's just go over and we will SSH as the Vault user. And then inside data config, let's just remove that file real quick. And we'll run that one more time. And now it restarted our Vault service. So that looks good. Let's see if it's actually working. If we go over there and run podman-a, that'd be the wrong thing. Podman ps-a, there we go. Created 11 seconds ago, up 11 seconds. So that certainly looks okay, but if we disconnect and wait about 6 seconds, say, and then we go back in there and run podman ps again, okay, it took a bit longer, but now that I come back in here, you can see it's been up for 1 second. Why was it up for 1 second? Well, the problem is login control by default does not allow long-running user processes in a systemd user session. So we need to fix that as well. So let's go ahead and disconnect and work on fixing that. Back in vault.yaml, after we create the non-root user, but before we get its home directory, let's just make sure the user has lingering enabled. So check vault lingering, and we can do a stat module, and the path is going to be var lib systemd linger and our username. And all we have to do is then register this as a result. So if this file exists, our user is allowed to linger. If it does not, they are not. So let's make sure they are. So we'll enable lingering for the Vault user. And we're going to run a command, and that command is going to be login control enable linger with the username, which is Vault in our case. And we'll add a when condition, and we'll say when not result.stat.exist. This means we'll get the stat property from result, and there's an exists boolean, and if the file exists, we're already lingering. We don't need to run this command. Now, is that super important? Not really, it'd be fine, but this is a way to make sure it's idempotent and it won't run the command more than once. So, other thing we need to do is say changed when, and the answer is true, because basically, if this command runs, then this command changed something. If it didn't run, then nothing got changed. But Ansible doesn't have a good way to know when a random command you might want to run on the server would make a change. So it can't decide that. So Ansible will warn you if you don't have the changed when property. So we'll go ahead and add that. So hopefully if we enable this, this should fix all of our problems. So let's go ahead and try that out. We'll go back and we will run the playbook for setup Vault one more time. I'm realizing I forgot to add become, so that's going to fail. Let's go fix that too. So become should be true. We'll save that. We'll go ahead and cancel that and run that one more time. There we go. Now it enabled lingering. And if we go back into this, we'll see Podman PSA. This is when it created about 9 seconds ago. I don't think 9 seconds have passed, but because we're lingering now, everything should last a lot longer. So I'll be right back. I want to sleep for about 30 seconds, and you need to disconnect before you do that, because so long as that user session is running, it would have been open anyway. So we'll disconnect, sleep 30 seconds. When I come back, I'll show you that it is still running even after that time break. Let's see if I am a liar. If we do podman ps, about a minute ago. So yeah, everything is still running. If I log in solely as the Ansible user and do sstln and I grep for port A200, yes, it is listening. So our service appears to be up. We're getting really close. But unfortunately, we won't be able to connect to our new Vault server from anywhere other than the ATH proxy host. And that's going to limit its usability. The reason is the firewall we set up in the last episode. It is blocking port A200. So we need to allow that on the WAN interface. So let's go back to our router role in the nftables.conf and let's make a few changes here. I'd like to make a directory where any file that gets added here is included in the firewall. So let's add another include statement, etc nftables rules.d star.nft. So any file with the extension nft will be included in our firewall policy. We'll need to go ahead and make sure this directory exists because right now it does not. So let's open the task file on the configuration section. And the first thing we'll do over here is I'm going to create the new directory. To do that, we'll use the file module. The path is going to be etc nftables rules.d. The state is going to be a directory, and the mode is going to be 0755, or maybe it should be 0700. That's probably correct. Okay, that seems like that ought to be good, so we'll have our new directory. Now we need to go ahead and add our rules. So back at the end of Vault, let's add a new task down here, and we will add our nftables rules for HashiCorp Vault. And we're going to use the copy module again, and the source is going to be file, destination is going to be /file, and we'll put some vars in there, and the file is going to be etc nftables rules.d HashiCorp vault.nft. Let's take that out right there. And then the mode for this file is going to be 0600. I don't really think it matters if it's role readable, but it's fine either way. So this should all work here, assuming we had this file. So let's go ahead and make that. So over here in not our router, but our Podman files, in etc, let's make a new file, nftables rules.d HashiCorp-vault.nft. Okay, and over here, we'll go ahead and add our firewall rule. So I'm just going to add this rule right here inside the IP filter in the input chain. We're going to add a new rule to accept port A200 traffic. Okay, that should be good for our firewall. One more thing I forgot is to add a handler, because if this file changes, we need to restart nftables. Now, because we're not using the router role anywhere in this play, this handler in the other collection is not going to be in scope. So I don't know the best way to handle this, but we're just going to go ahead and copy that handler over into our handlers locally. So let's go back up here to our Explorer and our handlers. At the bottom of our file, we're just going to re-add this. Okay, that should be good for this. So I think we are ready to try this out now. So the first thing we want to do is we want to run the router playbook, not the Vault playbook. We need to make that rules.d directory. There we go, and because we made a change in the config, it did restart nftables. Nothing was changed though, so we have to also add our Vault playbook. So let's go ahead and run that as well. And once again, I forgot to add become. Just a second. Okay, there we go. That looks good. We have restarted nftables. So if we SSH into there as the Ansible user, first of all, after all this time has passed, is our service still running? Yes, it is. Good news. Now if we do sudo nft list rule set, you can see we are now accepting port A200 in our input chain. So that means we should be able to connect to this service. Let's go find out. In my browser, I'm going to go to HTTP, and it's going to be ATH proxy local.net port A200. And if I do that, yes, we get into our UI. So I'm just going to do something dumb for now. It doesn't really matter what it is. We'll just say one thing. That's whatever, that's fine. Okay, I will download the key files. We'll go ahead and unseal that. If I go look at those files again, let's see here. I want this one. So here is my, I need my unsealed token, the base64 encoded one. So let's copy that. And we'll go unseal this. And then I can use my root token to log into our vault. Hey, looky there. We now actually have Vault up and running. Just real quick before we go, I wanted to point out that yes, the service does launch on boot. So I went ahead and you can see port 8200 is listening here. I did a sudo reboot. It did reboot. I waited till it came back up, logged in, and immediately it does run. So our vault will run on startup as the vault user. I would have liked to show off using Ansible to look up secrets from the HashiCorp Vault instance we just set up, but I think this video is already running pretty long, so we'll have to tackle that in a future video. But we have achieved the goal of this project. We created a Fedora virtual machine, we configured it as a NAT router and firewall, and we set up Podman to run our HashiCorp Vault container. So I would say this is all a success. I hope that you enjoyed the project and how this series is going so far. If you did, I'd appreciate it if you hit those like and subscribe buttons. It really helps out the channel. Thanks for watching. I will see you next time.